Alright, in this chain rule video, we're going to start out looking at the combinations of rules. And by that, we mean combinations of chain rule and product rule, chain rule and quotient rule, or perhaps all three. So the first example I've got is obviously a product of two functions. But the functions themselves require the chain rule to take the derivative. So, without further ado, h prime of theta is, you use f prime g plus g prime f as your recipe for the product rule, right? So this is like my f and my g. So the first thing is f prime. Now to take f prime, we've got to do the chain rule. The outside function is squared, and the inside function is tangent of theta. So f prime is 2 tangent of theta. That would be like the derivative of x squared, times the derivative of the inside, which is secant squared of theta. That's f prime times g. Plus, I'm going to start a new line. In practice, you're probably not going to do this on the page, but on the new line, I'm going to have g prime first. Now g, the outside function, is cubed, and the inside function is secant. So we're going to have 3 secant squared, just like the derivative of x cubed is 3x squared, times the derivative of the inside, derivative of secant, is secant tangent. That's g prime. And finally we multiply by f. Which is tangent squared theta. Okay? So each of these yellow derivatives here was itself a chain rule. Let's do the same kind of thing. Phone time. Okay, so that was an example combining chain rule and product rule. Let's do one combining chain rule and quotient rule. Q of x square root of 2x plus 7 divided by, let's do x squared minus 1 to the 10th. Big enough that you wouldn't want to actually expand it. Okay, again, this is obviously a quotient, but the individual functions themselves will require the chain rule. Alright, recipe for the quotient. So this is our f and our g. And our recipe for the quotient we've been using is f prime g minus g prime f over g squared. That's what you've been using, right? That specific formulation. Okay. Q prime of x. Let's go ahead and make a giant fraction bar. Giant fraction bar. We can take care of the denominator, no problem. X squared minus 1 to the 10th squared, which, if you like, let's go ahead and say x squared minus 1 to the 20th. Now, here's our f. F prime. Thinking of this as 2x plus 7 to the 1/2. Two x plus 7 to the 1/2 yields 1/2. 2x plus 7 to the minus 1/2. Now we've got to multiply by the derivative of the inside. No big deal. That's 2. Times g, which is x squared minus 1 to the 10th. Minus, now we've got to deal with g prime. Of course, the outside function is 10th power. So we have 10 x squared minus 1 to the 9th times the derivative of the inside function. Derivative of x squared minus 1 is 2x. So far we've dealt with f prime, g, g prime. As is our custom, we're running out of room. We extend our budget for the fraction bar and finally multiply by f. 2x plus 7 to the 1/2. Okay, so there's a couple of examples of combinations of rules. To be honest, it doesn't get much harder than this. So if you can do this, you are a licensed differentiation expert.